Hey, what's up, my 10th graders? A shout out to you. Hope you guys are doing well. First, before I start with today's second online lesson, I want to let you guys know that it was really cool talking to you guys this morning. I'm glad that we were able to clarify some of the doubts. I have been receiving a lot of your biology work along with your math work, so keep sending them to the email that I provided. I am going to verify and work to see if I can fix the glitch or the problem that's been happening with my school email, but nonetheless, you can keep sending me your work through that email. I have been receiving them. If some of you still haven't sent your math or biology work, you have until Friday to send the math work along with the exercises that I'm going to give now, and you have until Saturday to send the biology work, all right? So with that in mind, guys, let's get started with your second Algebra 2 class. Yay! You know you miss me. You know you miss me. You know you miss falling asleep in my class, right? I know you do. Anyway, here we go. So today's topic is graphing a quadratic function in intercept form. Now in the previous class, or the previous video rather, I gave you guys how to do it with vertex form, and I gave you some guided practice exercise. What I'm going to do today is I'm going to explain these exercises, which are from page 247 248, okay? So on page 247, the exercise, and pardon me as I go in and out real quick. On page 247, example number 3, which is y equals 2 times x plus 3 times x minus 1, okay? So once again, 2 times x plus 3 times x minus 1. Now, before I get into the exercise, let me go over this real quick. So, here we go. What is intercept form? So, there is a formula. The formula is y equals a times x minus p times x minus q. So, the first thing we're going to do is first identify the x-intercepts, then find the axis of symmetry, and the last step is going to be to graph them. So, it looks harder than it really is. In reality, this is very simple, very easy. And always taking it into account that if a is greater than 0, the graph opens upward and it smiles. And if a is less than 0, the graph opens downward and it frowns. Yeah, I know, I look goofy, but, be nice. Don't make fun of me and hurt my feelings, okay? I'm trying to be fun. Anyway, let's get started with the exercise. So, the first exercise is example number 3 on page 247, which is y equals 2 times x plus 3 times 2 times x minus 1. So the first thing we're going to do, ladies and gentlemen, is actually identify our intercepts. Now remember, just like when I was explaining vertex form, that if there is a plus 3 in reality, that means that it's not a plus 3, but it's a minus 3. So you're going to turn this into x equals negative 3, and then if there is a minus 1, in reality that's a plus 1. So we're going to turn that into x equals 1. So since these are my x-intercepts, that means that y is always going to equal 0. So we're going to say this ordered pair is negative 3 and 0. And this ordered pair is 1 and 0. Okay? So I always advise you to graph them as you keep obtaining the points. So my advice is to draw the coordinate plane. And this is going to be 1, 2, 3, negative 3, 0, and 1, which is about here. So I need to find my x-intercept. Now I know, or not my x-intercept, my axis of symmetry, or my vertex. And I know that the graph itself opens upward, so it's not going to have a maximum, it's actually going to have a minimum. So how do I do that? So step 1 is this, which we already did. Step 2 is to find the axis of symmetry by adding p plus q over 2. And we're going to say, in this case, negative 3 plus 2 divided by 2. Negative 3 plus 2 is negative 2, and negative 2 over 2 is negative 1. Now our third step is to find the other point for the axis of symmetry. So I know that one of them is actually going to be negative 1, okay? So we're going to say step 3, we're going to do it down here. This board is not as big as the one I have in class, but it'll work. By the way, I hope you guys are enjoying the format in which I'm recording the video, taking the suggestion given to me by Lyda. So shout out to her. Hope it works, all right? And if it doesn't work, you can blame her too. No, I'm just kidding. Hopefully you guys are going to be able to see this in a better quality. Anyway, so we're going to simply write in the function, and we're going to say y equals 2 times x plus 3 times x minus 1. And what you're going to do now is simply plug in the numbers. You're going to say y equals 2 times x minus negative 1, or plus, 2 times negative 1 plus 3, and negative 1 minus 1. So what we're going to do is we're going to add them, okay? Or we're gonna work with our parentheses first, right? And then we're going to multiply. So negative 1 plus 3 is actually going to be 2. So y equals 2 times 2. And negative 1 minus 2, guys, is actually going to be negative 2. So negative 2. And you're going to multiply 2 times negative 2, which is negative 4. And y is going to equal 2 times negative 4, which is negative 8. So y equals negative 8. And what that means, ladies and gentlemen, is that my other ordered pair is now x is negative 1 and y is negative 8. So you're going to graph that here. 1, 2, 3, 4, 5, 6, 7, 8. And that'd be here. So guys, then we just kind of connect the dots. And if you don't like the way my graph looks, draw it better in your notebooks. No. Just kidding. Or maybe not. Alright, so there you go. So this would be negative 1 and negative 8. 1 and 0. And then here on this side is 3 and 0. So there you go. That's the example. I'm going to step off camera real quick so you guys can look at it. Step 1, step 2, and step 3. Okay, down here again. Step 1, step 2, step 3, and then we graph. So I'm going to give you a minute to do that real quick. All right, so look at it. The good thing about this video is you can pause, rewind, go back. I am going to erase it though, so here we go. 1, 2, 3. If you didn't get to copy it, well, you can just rewind the video and check it out again. All right, so moving on. So that was example number 3 on page 247. We're actually going to go to example number 5 also on page 247, okay? So example number 5 on page 247. I'm actually going to rewrite example number 5 here so that way I have more space. Example number 5 on page 248. Okay, example 5. Give me 1 second while I rewrite it. Example 5, page 248. And that would be y equals negative 2 times x plus 5 times x minus 8. And what we're doing is we're changing from and again you can go to your books. We're actually changing from intercept form to standard form. We're changing from intercept form to standard form. Okay, so if you don't remember, standard form was this: f of x equals ax squared plus bx plus c. So we're actually going to turn intercept form into standard form, and then we're actually going to do vertex form into standard form. Now they look complicated, but they're quite simple. So the first thing that we're going to do, guys, is we're going to leave the negative 2 alone. And we're actually going to use FOIL to multiply this times this. So what you're going to do, guys, is you're going to multiply x times x, which is going to be x squared. Then you're going to multiply x times negative 8, which is going to be negative 8x. Then you're going to multiply 5 times x, which is 5x. And then you're going to multiply 5 times negative 8, which is negative 40. Okay, so real quick, what I did was I multiplied x times x squared, x times negative 8, negative 8x, 5 times x, 5x, and 5 times negative 8, negative 40. Now, just like when we use FOIL any other time, we're basically going to combine like terms. So the negative 2 is still, and pardon my y's, for some reason my y's are looking like v's today. Better. We're going to leave the negative 2 express, and then we're going to combine like terms. So the x squared is basically, I'm going to pass that over because there's nothing you can combine it with. Negative 8 plus 5 is actually 3, so that's going to be 3x. And minus 40. I'm still not done because I have a 2 outside of the parentheses. So, yup, you guessed it. You're going to distribute or multiply the negative 2 by everything inside of the parentheses. So y is going to equal negative 2x squared plus, and then negative 2 times, and then negative 2 times 3 is minus 6x, and negative 2 times negative 40 is plus 80. And now we have this in standard form, ax squared minus bx, or plus bx. Plus c. Now it doesn't matter that there's a minus sign here and that there's a plus sign at the beginning of the formula, because remember that when you're adding a negative, it's the same thing as subtracting, okay? So I'm going to step off camera real quick so you guys can take a look at that, all right? Once again, what I did is I used FOIL for this, and that's where I got this answer, and then I multiplied the negative 2 times everything that's inside of the parentheses, and I was equals negative 2x minus 6x plus 80, and that's it, guys. That is it for that example. So I'm going to step off camera and give you a minute to look at it, and then I am going to go on to the last example of the class, all right? So give me 1 second. Okay, you can look at it, see, verify that everything is okay. I am going to actually look at the last example here in your book so that you have an idea of what we're doing. And with that in mind, ladies and gentlemen, I'm going to erase this, and then we're going to do the last example. This is example number 5 on page 248, so you can go to your books and look at it again. All right, and now the last example of the class. And with this last example, we're actually done with this section. So I'm going to rewrite it here, and this is going to be example number 6 on page 248. And example number 6, we're actually changing from vertex form to standard form. And the exercise is on page 248, example 6, it's 4 times x minus 1 squared. So y equals 4 times x minus 1 squared plus 9. Okay? And what we're going to do is very similar to what we did in example number 5. I'm going to leave the 4 expressed, and I'm just going to bring it down. So y equals 4. And then I'm actually going to expand this. Expand this into x minus 1 into x minus 1 times x minus 1 plus 9. And I'm following order of operations. I'm actually going to multiply this by using FOIL. So once again, the 4 stays expressed, and you're going to say x times x is x squared, and then x times minus 1 is minus 1x, and minus 1 times x is minus 1x, and then minus 1 times minus 1 is plus 1, and all that plus 9. Okay, so then what we're going to do is we're going to say y equals 4 times, And we're going to leave the x squared expressed, x squared. And then negative 1 minus 1 is actually minus 2x plus 1 plus 9. Okay, so we're still following our order of operations, which means we're going to multiply and then add. So we're going to say 4 times x squared is 4x squared. 4 times minus 2 is minus 8x. And 4 times 1 is 4 plus 9. Now notice that the sign of the 9 doesn't change, and it's because we didn't move it anywhere. We just distributed the 4 by what's in the parentheses, and we just let the 9 express. So now we're going to combine like terms again. Y equals 4x squared is actually going to stay expressed, minus 8x. And then 4 plus 9 is 13. So plus 13, and that's it, guys. We have our answer expressed in standard form, okay? So once again, real quick, what we did was we expanded x minus 1 squared into x minus 1 times x minus 1. We used FOIL. X times x, x squared, x times minus 1, minus 1x, minus 1 times x, minus 1x, and minus 1 times minus 1, plus 1. And then we combine our like terms, so x squared, I pass that over, negative 1 minus 1 is negative 2x, and I pass the 1 over. Then I use my distributive property and I multiply 4. 4 times x squared is 4x squared, 4 times minus 2 is minus 8x, and 4 times 1 is 4. And then bring down the plus 9, and then 4 plus 9 is 13. And you have y equals 4x squared minus 8x plus 13. And that's it, guys. That's it. That is the end of the section. That is example number 6. It's on page 248. You can follow those examples. Example 3, example 5, and example 6 in your book. Example 3 is on page 247, and examples 5 and 6 are on page 248. But since I said that this isn't a free ride, you know you miss me. You know you miss me. You know you miss falling asleep in my class. No, I'm just kidding. Well, maybe not. You do fall asleep in my class, but that's beside the point. What you're going to do, guys, is you're going to go to the guided practice on page 247. And you're going to answer problems 5 through 7. And then you're going to go to the guided practice on page 248. And you're going to answer problems 9 through 11. The same thing you did for the previous example. You're going to take a picture of it using camera scanner. Or if you want to flex that you've got an iPhone and I've got an Android, you can take a picture from your iPhone. All joking aside, though, I am actually contemplating that, changing to an iPhone, but I don't know. We'll think about it. Anyway, guys, all joking aside, these are the exercises. Guided practice, page 247, problems 5 through 7. Guided practice, page 248, problems 9 through 11. You can send them to either one of these emails, jmarquez@fbspr.com or mr.j.marquez84@gmail. Now, shout out to those of you that have been sending me your biology work and your math work. I have been receiving it. This week, I want you to focus on that biology work, so I want you guys to finish that. The due date for that is Saturday, although a lot of you have been sending it in ahead of time, which is cool. The due date for the math work is on Friday. So as soon as you get this video, as soon as it's uploaded to YouTube, you can go ahead and you can start working on that. I'm also going to post it on the LMS of your College One. Ladies and gentlemen, if you've not subscribed to my YouTube channel, it is Maestro Frobel J. Marquez. J. Marquez, not J-A-Y Marquez, but Maestro Frobel, letter J, Marquez. Look for me on YouTube, hit the subscribe button, hit the bell so you get the notifications every time I'm uploading your video content. Stay safe, be careful, and I'll see you in the next class, guys. So this is your favorite teacher signing off. Bye.